Greetings. Today we're going to talk about covalent bonding. We have already discussed ionic bonding, but now we're going to move on to a more significant bonding. Get it? Get it? No, maybe not. All right, let's move forward with this. A covalent bond is a bond between two atoms. The purpose of it is to achieve, for each atom, to achieve a noble gas configuration, just as for ionic bonding. But in covalent bonding, they are going to share in covalent bonding, they're going to share those electrons in order to achieve a noble gas configuration. So what is the purpose for bonding? Is to obtain an octet or a duet. The definition of a covalent bond is two or more valence electrons shared between two atoms. Now, they may be shared in several ways. We're going to talk about that a little later on. We can have one bond, two bonds, or three bonds. Where we have a single bond, we are going to show it as hydrogen. So I'm going to say hydrogen has one electron. And notice that I've turned the electrons around so that our bonds can work out. And this hydrogen has one electron. I can also write it with a structural formula like this, where this is H2, hydrogen gas, which is a diatomic molecule. And this is what the molecule would look like. They're sharing one pair of electrons, and I show that by one single bond. Then I have the next one is oxygen. So I'm going to draw oxygen, and we know we have 1, 2, 3, 4, 5, 6 electrons. And I'm going to do a mirror image of that. 1, 2, 3, 4, 5, 6. Remember I told you we would turn them around. These two will be shared, and these two electrons would be shared. So now I'm going to rewrite that as O, bond, bond, O. I could show the dots as well. I could show dots here, dots here, dots here, and here. But generally we just show the bonds with the lines. Finally, I want to show you nitrogen. Nitrogen forms a triple bond. So we have single bond, double bond, and a triple bond. Why does nitrogen form a triple bond? Nitrogen is also a diatomic molecule. It contains 5 valence electrons. I just kind of know that, but if you need to, look at your periodic table. So I'm going to say 1, 2, 3, 4, 5, and I'm going to do a mirror image of that. I'm going to do 1, 2, 3. I'm going to do the mirror over here and over here. All right, so now I know that these two will be shared, these two will be shared, and these two will be shared. So they will have a triple bond. A nitrogen molecule will have N dash 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 N, and then I'll put the 2 dots, extra dots out here. And we're going to do many more of these. So there you have it, single bond, double bond, and triple bond. All right, besides having single bonds, double bonds, and triple bonds, there are several ways that atoms can share. For that, I want to show you this little video clip. I am Agent Boris from Ukraine.
I am Agent Stroganov from Russia.
Are you ready?
I am ready. In 3, 2, 1.
Are you ready?
I am ready. In 3, 2, 1.
So you just saw that there's a variety of ways to share. We can share equally, we can share unequally, and we can share or not share at all. We can have an ionic bond where one takes and the other one gives the electrons. But how will we know? Well, basically we're talking about, in covalent molecules, we're talking about nonpolar and polar covalent bonds. A nonpolar covalent bond involves equal sharing. Equal sharing of electrons. If they're sharing electrons, they're being shared equally. If my elbows are the two atoms, there's equal sharing. Polar covalent bond, there's unequal sharing. Okay? Let's say this. All right, it's hard to do with my elbows, but they are not sharing equally. So, let's give an example. Equal sharing would be two atoms that are identical. For example, I could have Cl2, the molecule, and I have Cl and Cl, and I'm going to have 1, 2, 3, 4, 5, 6, and let's do the seventh one here. Mirror image. They're going to be sharing one bond. However, this bond has to be an equal sharing because they're the same. They have the same, what we call electronegativity, which I'm going to get to in a minute. Then we have a polar covalent bond where, for example, HCl. HCl pulls the electrons, or Cl pulls the electrons closer to this side, making this side slightly more negative. And we show that by a sigma symbol with a negative charge. And on this side, we show that this is slightly more positive because only the protons are in this area and the electron has been pulled away, and we show this as a sigma bond positive charge. Meaning that we also can draw an arrow pointing to the more electronegative. But what are you talking about, Missy? We haven't gotten to electronegativity. Hold your horses. It's coming. This is a chart that you would be given, or you would be given this information. You need to know the electronegativity numbers. You're not going to have to memorize them. But I want you to notice some things. As we move across a period, this is 0.93, 1.57, 2.04, 3.04, 398, 3.98, electronegativity increases as we move across the periods. And notice that we're over here, let's say 3.93, 3.16, 2.98, 2.66, electronegativity is decreasing. So I'm going to say it's increasing this way, and it's increasing this way. So which ones would have the highest electronegativities? These guys right up here. In fact, fluorine has the highest electronegativity. I've seen it 4, but there it says 3.98. So that is, it's a scale that was devised by Pauling. This is the only time in chemistry, I believe it's the only time, that you will use numbers without units, because it is a scale and it doesn't have any units. Pause, and I'm going to let you go ahead and copy this. All right, so now we know that if it is 0, the electronegativity difference is 0 to less than 0.5. And the other number that we need to remember is 2.0. Okay. From here to here, this would be a nonpolar covalent bond. From here to here, it would be a polar covalent bond. And beyond this number, it would be an ionic bond. So the tug of war gets so violent, it's so different that it's actually going to pull the electrons away. So they're not going to be shared. And this is a scale. It's not set on stone. It's a continuum more than a fixed number. All right, finally, let's take a look at a couple of examples. How do we figure out what kind of bond an atom's going to have, or a molecule has? Chlorine, for instance, we already said, if we look up chlorine, it's 3.16. So we have Cl, Cl. It is 3.16 minus 3.16. That's when we figure out electronegativity difference. So we take the difference of the two, and that is equal to 0. So therefore, looking at our scale that we had formerly, that scale told us that 0 would be a non-polar covalent bond. When we look at HCl, we have also looked at it. Let's 3.16 minus hydrogen 2.2. All right, so now we have HCl. We're 3.16. This is the electronegativity of chlorine. This is the electronegativity of hydrogen. And we end up with 0.96 electronegativity difference. The difference tells us that if that is 0.96, that is going to be, if you refer back to our previous example, we have a polar covalent bond. So therefore, there's one area that's being pulled, the electrons are being pulled closer to the more electronegative, which in this case is the Cl, and away from the hydrogen. Finally, KBr. Let's see what kind of bond that gives us. We have K, 0.82, and Br is 2.96. So I'm going to say 2.96 minus 0.82. And if I did my math correctly, it's 2.14, and that is above 2. So therefore, that's going to be an ionic bond. That is all for today. Have a great day.